Do you have any question?
No.
What is your question? Please make a question, one, at least one. As simple as, it's okay, simple or not. Please make one question, at least one each person. And type at Padlet. At your Padlet. Please make a question. A simple question. A simple question. Please ask. For hypothesis testing, do you have question? If no, please create your question. Please create a question, at least one. No question. Everything clear. So I have question for you. How many method to to step in a hypothesis testing? How many method? One minute. 1 minute. Writing assignment tu kan? Saya kelas ni takut dengar. Saya kelas ni takut dengar. Okay. Alright, so there is 3 method. We have traditional method, p-value method, and confidence interval method. Alright, so in hypothesis testing, so this is the most important, because this is the first step for the before we go to the inference of statistic. So hypothesis testing, we have two hypotheses, null hypothesis and alternative hypothesis, which is, for null hypothesis, we assume to be true until the sample evidence indicate otherwise. And then alternative hypothesis, a claim to support based on the sample evidence. So, and then we have, why this happen like this? And then we have denoted as for null hypothesis, we denote as a hash null, and then for alternative hash 1. Okay, and then for null hypothesis that we are trying to reject always contain no difference or no effect. If we fail to reject the null, and then the result is obtained purely due to the chance. And then for the alternative hypothesis that we are trying to support opposite of the null, then there is a different an effect if we reject null and the result is obtained due to the real effect or non-random cause. Okay, we can see the example there. We have a statement for the hypothesis, and then another example there we have a symbol, which is we use for null hypothesis. H null equals to nu equals to 20 mm, and then nu not equal 20 mm. So we can use both lah. So you can use both to represent our hypothesis, but you need to define first lah. New one, what is the new one? New one is a number of all defect item from machine A, and new 2 is the mean number of all defect item from machine B. So that is clear to us to use the hypothesis. Okay, we also can use in null hypothesis we use two new, which is a new equals to new 1 equals to, we assume that new 1 is equals to new 2, and then new 1 is not equal to new 2. It depend on the question, which is when the question, if we want to find there is no difference in the mean number of all defective item between the two machine, and then new 1 not equal to new 2, which is represent on there is a difference in a mean number of all defect item between the two machine. So you need to play around with the keywords. Okay, keywords. If we can see the first example, the keyword is no effect, and another one is an effect. But for second example, H null is nu equals to 20 mm, because of the statement there is the mean length of all screw is 20 mm. That we need to play around with the keywords. What is the keyword for to create the H null, the hypothesis? And then also the another thing that important is we need to identify what type of the test that we want to use, which is we have three type. We have right tail test, left tail test, and two tail test. So this thing is effected for you to construct the hypothesis. Okay, clear? So there is three element. First, the keyword of the that we want to test the given keyword, and then the test that we want to construct, and then is it the symbol that we use represent clearly or not. So there is three things that you need to consider, and then you can construct the hypothesis. After you construct hypothesis, you can you will face three type of error, two type of error. You will face two type of error. So the error that we will face first type error. First type error, it happen if your statement, okay, here we can see it's happen when your statement we can see here if the statement H1, you should you assume that H1 is true, but after we make analysis, we reject the H1. Actually, the H1 is H0 is, if H0 is after the analysis, the H0 is rejected. But actually, the H0 is correct. That's happened. But from the analysis, from your data analysis, from your testing analysis, and then you see that you from the figure that come out, you conclude that we reject the H0. Actually, the H0 is true. So we call it as a type 1 error. Okay. Okay. For the for the type 2 error, it's happen if, okay, if the H0, we fix H0, if H0 tadi so H0 is false. Okay, if H0 is actually false, and then from the data and then from the analysis we make, the figure make us conclude that the H0 is correct. It meaning the H0 is correct. So we conclude the wrong type 2 error. That the type 2 error will happen because we correct the actually the H0 is false, but we say it as a true. H0 tu betul, salah, tapi kita cakap betul based on the figure yang kita ada. Tapi the type 1 error, H0 tu betul, tapi bila kita buat pengiraan, buat analisis, and then kita mendapati benda tu, kita katakan, kita conclude, kita buat conclusion H0 dia tu salah, padahal H0 tu betul. Itu kita akan bincangkanlah kat sini nanti. Type 1 error and type 2 error. Macam tak nampak lagi kan contoh dia tu. Okay. So you all ambil yang paling mudah lah untuk you ingat, which is ambil satu je. So contoh H0 betul, tapi you reject H0, and then we call it as a type 1 error. Okay, you ingat satu. Yang kedua tu you reverse lah, you reverse dia punya ni. You jangan ingat dua-dua. Biasanya kalau ingat dua-dua ni jadi confused. You ingat satu lah, and then another one is different, opposite lah. Another one is opposite. Alright, so we go to the step in hypothesis testing. We have traditional method, p-value method, and confidence interval method. So we have traditional method, we have 5 steps. Every method we have 5 steps. So first of all, identify the claim, which is hypothesis tadi, which is yang kita cakap hypothesis ni, yang tadi example of hypothesis in this page. So we construct a claim, and then we obtain the critical value. What is the critical value that we want to consider? And then compute the test statistic. Z. And then fourth step is make a decision to reject or fail to reject the null hypothesis. Make a decision to reject. From the data, we compare Z and Z alpha here. We compare. Okay. And then state a conclusion. After we make a decision and make a conclusion, in context the problem and the claim, context on this lah. Okay, let's see. Here we have this is testing for mean. We have hash now new equals to new not, and then h1 equals to this. Okay, the different here. Okay, the different is we have three different. The different based on left right tail or two tail or left right or two tail. So we have based on the different is based on tail. What we consider. Okay, so and then here we can see if left tail we have less one, and then if a two tail we have equal not equal for h1 lah. So here we have a rejection region. So we have n greater or equal to 30 if n is greater or equal to 30. So we have this kind of region that we need to consider to reject. If less than 30, we use t test. We use t test, and then this is the confident. I think I need to draw so make easier to you to understood what actually this want to describe here. So we have left tail. Left tail we have okay, left tail we have this area. Okay, this area of rejection. Okay, this area of rejection here, and then we said that, so which is this is a z alpha. So that's why here you want to reject this area, meaning if z yang kita calculate tu, if z is inside here less than z alpha, so the z alpha, so it goes to this rejection area, so that we reject the statement. But if the data if the z is here, maybe something here, so we not reject lah that test. We accept our claim. And then for right tail we have this area. So we have this area, and then if z here we calculate, and then we have the z alpha here, the value of z alpha here. So the value of z alpha, for example, 1.796 for example. So if z greater than 1.96, for example, we have 2.5. So it meet this he drop to this rejection area. So we need to reject our claim. But if z yang kita kira kat sini kira kat sini, so we kira dia dapati dia z is less than 1.96. So maybe dia dekat sini lah. So maybe dekat sini. So dia adakah di dalam rejection area? Is it inside of rejection area or not? Is it in rejection area or not? Rejection area dia tak ada dalam dekat rejection area dia kan. So perlu kat kita reject kita punya claim? So tak perlu. So sebelum kita untuk kita buat decision ataupun buat conclusion tu, saya wajibkanlah untuk draw this picture, so that we can know is it the data, the test in the rejection area or not. This is for two tail. Only if the test inside here and here, we reject the claim. But if the the value is inside here, so we accept the claim. Okay, and then this is the formula to calculate Z here. So this is formula to calculate Z here. As usual, we have known and unknown data. We have this known data. We use this formula. Unknown data separated by number of n, which is n greater or equal to 30. So we will use this formula. But if n less than 30, we use this formula. Okay, I think that is... Okay, we go to the example so that you can imagine what I mean lah. Okay. Okay, a sample of 30 internet shopper was asked how much they spend per year on the internet. From this sample, the mean expense per year on the internet is 1,300. And the sample standard deviation, okay, this is the mean, mean. So this is the mean. Teruknya dia punya ni. Good. So this is the mean. Okay. And then the sample standard deviation. Sample standard deviation, this is as. So you just identify the information given. This is n. And then the test at confidence interval alpha 0.05. Alpha 0.05. Okay, we Z alpha here 0.05. 0.05. Okay, why we need to identify the claim first? Because we need to differentiate. Is it the claim is left hand side, right hand side, or two tail? So in this claim, okay, is sufficient evidence to reject the claim that the mean of yearly expense is. So this meaning new, the definition for new, this step 1, the definition of new is mean yearly expense on the internet. So meaning new is equal, because is RM 1,500. This is our claim. Okay, and put a bracket here, our claim. And the hash now will be new is not 1,500. So if this happen, so this hypothesis, the hypothesis here show us the testing will be two tail. Okay, two tail. So two tail. So once kita dah identify the two tail, then we need to divide 0.05 here, divide by 2. So Z alpha here, alpha yang kita nak consider will be 0.025, which is Z alpha 0.05 is Z alpha, bila kita tengok kat belakang buku, so it equals to plus minus 1.96. Okay, in between this area. So negative 1.96, 1.96. Okay, settle this thing. So kita settle, also kita settle second step, which is to find the critical value. Because of this is two tail, so we should divide 0.05 over 2, 0.025, and then we get this thing. And then Z, we need to compute the Z, because we want to compare here. So we already have Z alpha. So now we need to find the Z value. So the Z value here, okay, the Z value here, okay, the Z value here, so n 50, so it is greater and equal to 30, and then mean is, use this formula. So this is unknown data. We do not know how many data we will get. So the real data that shop online, we do not know. So unknown data, and then we use this formula, and then we get negative 1.286. Okay, once we get this value, so make a decision to reject or not to reject. So we need to identify where is negative 1.286. So where is negative 2.6? So if we draw this diagram, we have negative 1.96 here, and then negative 1.286 here. So this line is not in a rejection area. So since z-test negative 1.286 is not fall in a rejection area, so it's failed to reject H null, and we accept H null. So we conclude that we just copy the H1 punya, kita punya claim dia tadi. Apa kita punya claim? The yearly mean expense on the internet is so there is not enough evidence or insufficient evidence to reject the claim that the internet shopper spend on 1,500 per year on the internet at the 5% confidence interval. So this is the keyword that you need to put. This is the keyword, the claim lah. Sorry, the claim. Reject the claim that, and then you teruskan dengan dia punya claim based on the question, and then is it the not enough evidence and insufficient evidence, or enough evidence to reject is. So you manipulate here lah. Alright, boleh tak? Boleh tak sakat tu? Boleh tak? Boleh tak? Senyap je. Tiba senyap kan. Okay, my question here, if type 1, type 2 error happen, so what type of error here will be happen? What type of error will be happen here? Type 1 or type 2? Type 1 or type 2? Kelas. Senyap je. Dia akan jadi type 1 or type 2 error ni. Ya, dia akan jadi type 1 ke type 2 error?
Type 2 lah type.
Ha?
Type 2.
Type 2 error eh? H1 type 2 error. Fail to reject H now. Type 2 error if sebenarnya H1 H0 dia salah tapi kita terima. Yes, dia akan jadi type 2 error. Betul. Okay, boleh? Faham tak apa maksud yang tadi, yang mula-mula tadi kan? Dah nampak kan dia punya apa? Consequence dia. Dia punya flow dia. Okay. We have another method. We have another method which is we call as a p-value. P-value method. We have p-value method which is applied in solving a hypothesis testing problem. It is probability obtain a value of statistic z as a more extreme and the calculate test statistic value z test and z calculate or z calculated. From the samples data, then assumption they will know hypothesis is true. The p-value is the evidence against the null hypothesis. Okay. Okay. So p-value is evidence. What? P-value is the evidence against the null hypothesis. Okay, so if H1 we have nu greater than nu naught, and then H1 okay, betul lah. The difference is nu and then here is P. Okay, if P Z is greater than ni, and then the P value here is here. So P value is P bracket Z greater and equals to Z test. And then the similar one with from the previous, but it just only use a P. Before this we use alpha value. Okay, so P value greater alpha value tadi, Z alpha tadi, we what we use the value of alpha. We use the value of alpha here, the Z alpha here. For P value, actually we use what is the value inside here. So Actually, that is the similar thing, but the just a different method. But, so that's why here, if you can see, it said that p value is less than or equals to alpha. Indicates strong evidence against the null hypothesis. Thus, we reject H null. If p value greater than alpha, indicate weak evidence against the null hypothesis. So here, if you understood here, the p value, what the p value here, it want to say that here, we not talk about the z alpha, we talk about the alpha itself. So it said that p value indicate p value greater than p value greater than alpha. So p value greater than alpha, what is the p value is greater than alpha? For example, if this is the alpha here, so this is the alpha, the rejection area. So now he said that the p value, so he said that the p value so the p value, dia kata, is greater than alpha. So the coverage of the p value, for example, the p value is greater than alpha. So meaning thus we fail to reject the H null, because dia punya value kat sini, kalau kita compare with the previous method, before ni kita katakan contoh 1.96 kat sini. So kat sini adalah 0.7, something like that lah. So dia less than ni. Cuma sekarang ni kita kira dengan menggunakan region area dia. Berapa region area. That's why dia punya statement macam ni. Benda sama. Okay. Pening ke pusing dah ni? Pusing. Dah pening lah. Alamak, macam mana ni? Okay. Dah pusing-pusing dah. Okay. Beza dia kat sini je. Macam mana kita nak compare tu. Benda sama je. Kalau kita compare, kalau you guna method ni, method yang pertama tadi. Method yang pertama, kita guna value dekat sini, kat bawah ni. Okay, dia tetap sama sebenarnya. P value kat sini adalah ni. Tu dia kata P value, this is alpha value. Dia yang merah tu alpha value. Yang biru yang saya ni adalah P value. P value. So dia kata P value greater than alpha. Kan? Betul tak? P value greater than alpha bermaksud dia punya ni adalah ni kat sini. Value dekat sini. So that's why dia kata fail to reject. Dan dia kata fail to reject. Dah nampak dia punya beza dia. So dia kata there is weak evidence, thus fail to reject. So we accept lah. So macam tadi yang atas tadi kita accept kan. Kita accept ni yang atas. Pening lagi, pusing lagi. Dia pusing sikit lah. Cara tu dia pusing sikit. Boleh? Boleh tak? Okay, cuba kita tengok. Boleh Okay, cuba kita tengok kat sini. Dia kata Z alpha equals to negative 1.286. And then we compute the P value. We compute the area on the left. Area yang the shaded region tu. Shaded region dia adalah So negatif 1.29 ni area dia adalah 0.5 tolak this. And then yang ni tengok table, yang ni kat table. Yang ni table. Ni table. Ni value dia daripada table. So dia dapat ni. And then 0.5 tolak ni kita dapat this area. So benda sama, cuma area yang kita consider kat sini, total area dia adalah this. Okay, boleh? Okay, since it's two-tailed, P value is twice of this. So kita kena darab lah. Dia two-tail kan tadi kan. Case yang tadi adalah two-tail, so darab 2. Okay, so sekarang compare. Kat sini kita make a comparison. Nak reject ke nak accept. So since P value 0.5, 0.9197 greater than 0.05, kita tahu value untuk Z alpha tadi 0.05, dia 0.05 kan, betul tak? 0. Dia yang ni 0.025, yang ni 0.025. So dia total dia 0.05. Teruknya dia punya ni hash. Saya tak tahu kenapa ni. Okey. Dah lama sangat saya buka tadi laptop ni kot. Patutnya saya tutup sebelum kelas tadi. 15 minit tadi. Okey. So kita ada total area untuk alpha ni. So dia kata there is 0.197 ni lebih besar daripada 0.05. So we fail to reject. Sebab apa? Sebab dia bincang melalui sisi shaded area. Kawasan yang berlorek. So kawasan yang berlorek tu lebih besar daripada yang berlorek merah. So bermaksud dia tak boleh nak reject. Maksudnya dia tak ada evidence yang kuat untuk reject. So kita kena accept lah. So that's why dia punya conclusion dekat sini. Dia kata there is not enough evidence to reject the claim. So itu je lah beza dia antara this method, P method dengan alpha method. Traditional method, they call it as this is a traditional method. Tu je. So depends lah. You jangan campur pula method ni. Kalau you campur method, you pening nanti nak buat decision. So you ambil salah satu. Okay, boleh. So again, kat sini dia just minta you guna benda yang sama, just step 4 ni yang berbeza. Dan step 4 ni kita boleh guna Excel. Nantilah hari Isnin malam baru saya bagi tahu macam mana nak guna Excel ni ya. And then sebenarnya you boleh buat sendiri. Sebenarnya you lagi advance ni daripada saya ni. So you boleh buat tak ni sebagai, okay, you test kat sini. You ikut dia punya using Excel ni. Ni sebagai you punya. So you cuba download. You cuba download Excel with 8. Kat sini kita ada kita ada apa Kita ada macam-macam kat sini. Okay. A topic, Excel function, big idea, terminologi, konsep yang nak kira-kira tu ya estimation of single mean ni. Estimation of single mean. Okay, you all buat. Ini sebagai you all punya proof of evidence yang you attend hari ni. Boleh tak macam tu? You guna yang ni. Sebab kat sini you boleh guna dua lah, manual ataupun pakai ni. Dan make sure you faham dulu. Terbuka benda lain pula Okay. Make sure you faham dulu. Okay, make sure you faham dulu. So, you boleh compute manual. And untuk proof evidence, you buat benda ni. Okay, you buat benda ni. And then, you dapat value ni. And then make a decision. Sebab assignment tu nanti, you kena guna benda ni. So, by hook by crook, you kena pandai lah guna Excel tu kan. Sebab you kena guna data yang assignment 1. Itu cerita dia. Okay, boleh? Buat decision. Step 4. Lepas kita dapat value semua ni, buat decision comparison lah. After buat decision, kita kata kat sini fail to reject. After fail to reject, we need to make a conclusion. Apa conclusion kita? So that kita tahulah in general dalam satu ayat. Alright? Boleh. Okay. Confident interval method. Confident interval method dia membezakan method-method ni adalah dekat step 4 and step 5 tu. Step ni lah. Step 4 compute ni. Step 3 and step 4 yang membezakan dia. Okay, step 4 and step 3. Okay. So confident interval method, kita pakai this formula. So dia pakai this formula. Okay, confident interval method kita guna macam ni je. Just kena illustrate dia punya interval tu. Okay, bila kita tengok dekat formula ni, kita akan dapat this interval. So, from this interval, kita tengok graphically, 95 confident interval for the population mean look like this. The null hypothesis statement new equals to this here, dekat sini. So is include in the interval. Dia masih lagi dalam interval yang kita claim tu lah. Thus we fail to reject. So that's all lah. So and then buat dia punya conclusion. So this is another explanation lah. So the relationship between the confident interval testing allow us to make decision about the hypothesis based on the interval compute. However, we can use only confident interval method for two tail. Untuk two tail sahaja only. Only two tail. Only two tail. Okay, only two tail. So only two tail test only. Okay, only for two tail for this method. So decision. Okay, this is a comparison between three method yang kita discuss tadi. Rejectional Z-test or T-test fall in the rejection area. P value is less than alpha. And rational is a statement. So, this is ni kita jarang guna lah. Yang ni kita untuk confident interval ni kita jarang guna. Tapi biasa yang ni. So depends pada you all selesa yang ni yang traditional ataupun P value. Depends lah you. Tapi make sure dia consistent lah. Kalau you pakai P value semua. Alright. And then hypothesis testing for proportion. So the similar thing here. So proportion. You will have 3 tail. Cuma beza dia proportion je lah. Dia punya DE ada statistical test dia. Ini dia punya formula untuk statistical test. So kita ada P naught dengan Q naught. Okay, and then sample proportion X over N. So this is the example oh kita dah terlebih masa. This is the example. And then the similar thing, we have 5 steps. So this step we have this first is claim, and then find the critical area, buat testing adakah dia reject dalam masuk dalam rejection area ke tak. Yang ni dia pakai p value. Kan dia pakai p value ni saya rasa ni. Ke dia pakai dia pakai biasa traditional method, and then buat conclusion. Habis itu je lah cerita dia. Summary of this today. So we have null hypothesis, alternative hypothesis. We collect the data, and then we test the data, and then find the rejection area. No rejection area. Yes if fail to reject. No is reject H now. So conclusion, not enough evidence. So kat sini dia dah buat decision lah, macam mana you nak buat decision. Okay, setakat itu je lah. So ada soalan tak yang terakhir sebelum kita habis kelas? So kat sini dia dah clear lah. You all reject once apa you nak tulis tu, dia dah buat dia punya jawapan dah. Okay, boleh? So itu saja untuk hari ini. Boleh tak? Itu saja untuk hari ini, kan? Boleh? Ke dah tak ada orang? Boleh. Boleh belah. Boleh belah dah. Okay. Itu saja. Thank you. So, that's all for today. Thank you for attending my class. Make sure you isi borang link attendance. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor. Thank you, Doctor.